All right, guys, 3 chapters left. Chapter 8, Chapter 10, and Chapter 11. And you'll have your last exam. So home stretch, hang in there. Chapter 8, we're talking about risk and return. Um, and we'll talk about how to measure that. Look at different stocks, portfolios, weightings, and do some different measurements for risk and return. So starting out, a quick example that might pique your interest, hopefully. Let's say you have $1,000 currently. So you have that much money right now. You can choose option A, 50-50 chance, so just a coin flip of if you're right, you win another 1,000. So I'm going to flip a coin. If you guess right, you win $1,000. If you're wrong, you don't win anything. Okay? Or you can choose option B. You just take the 100% guarantee and you win $500. I'll just give you $500. So you pick which one, A or B. Choose one, write it down. You can't change your answer. You got to stick with it. Okay? Think about it. You don't have to do any math right now. Just think, what would you do if this was a real scenario? And I'm going to give you the gamble or the sure thing. Which one do you pick? Okay? Write down your answer. All right. Once you get there, now another game. Now you have $2,000 in your pocket. You can take option A, 50-50, so you get a coin flip. This time, if you're right, you don't lose any money. You keep the $1,000 or the $2,000 you have now. Nothing happens. Or if you're wrong, you're going to lose $1,000. Okay, so you pick which one you want. You either take the gamble. You choose heads or tails. If you're right, you don't lose any money. If you're wrong, you owe me $1,000. Or you can just take the guarantee, 100% guarantee. Sorry, not 1,000, 500. So you lose 500. So which one do you pick here, A or B? Think about it, write it down. You don't have to do any math. You can if you want. Which one do you want? Okay. If you picked A and A, okay, then you're risk seeking. You like to gamble, you like to take your chances. If you picked B and B, you're more risk averse. Right? You took the safer bet, you just went with the guarantee on both. If you picked B and then A, you're irrational. And you're like most people. So most people choose the sure thing here, but then we take the gamble here. Mathematically, once we get into the formulas, you should either be more risk seeking or maybe more risk averse, just a personal preference. But to switch from one to the other, in theory, in economic theory, you shouldn't do that. But we find that most people do. About 60% actually choose this one. Now, some people may have chose A for the first one and then B for this one. You would be irrational again, but a more unexplainable irrationality. The reason most people choose the sure thing here with the choosing B, and then take the gamble here. It's called prospect theory. Basically, it means in the gains when we're positive. So here, we're more risk averse. We want the sure thing. We want to lock in those gains. But when we're hurt, when we're in the negatives, we're more risk seeking. So we'll take that chance. We'll take the gamble in hopes to get back to even. We don't like a guaranteed loss, so we're a little more risk seeking in the losses. Kind of plays in with gains are good. Gains feel good, but losses hurt worse. So it's a utility curve, and we won't get into all that. But it's a guy named Kahneman and Tversky, psychologist and economist, that came up with this a long time ago. And now it's been put into economic and financial theory and applied in all different scenarios. So we're not going to go this deep in the theoretical side of it, but it is a good jumping off point for us to figure out expected returns using probability and our expected payoffs if that does happen. All right. So moving forward with this risk and return and how we're going to actually measure that, we'll look at a few different things. First, let's talk about if we have different states of the economy. So this is that handout, Chapter 8, Risk and Return. I'll post it on Moodle. So if we have different states of the economy, like in this first example, we're given that there could be a recession, a neutral economy, or a boom economy. All right, and then we're given different probabilities, this PI. That's the probability or the likelihood that any of these things happen. So we've got 25% chance that it's a recession, 50% chance, just neutral, normal economy, and 25% that it's a boom. All right, and then we're given different expected returns for different stocks. So we've got stock A and stock B and different expected returns for each. So expected return for stock A, this is all in your handout. In a recession, negative 20%, neutral, 15%, in a boom, 35%. Expected return for stock B, 30%, 15, and 10, negative 10. Okay, so these are moving different directions. This is obviously an extreme example, but it is kind of true. There are different stocks that are going to do better in a boom economy, others that would do better in a recession. Think about, like your Louis Vuittons and Mercedes and these luxury brands. They're probably not going to do very well in a recession, right? When money's tight, when things are bad, people aren't going to spend as much in that sector. What might do good during a recession, probably not 30%, definitely not, but maybe Dollar General or your ramen noodles or things that as money gets tight, people will shift more towards and use more of those products and use those companies more so. All right, extreme example, but just to kind of paint the picture. All right, so we've got different probabilities of this state of economy happening, different returns if and when it does happen, and we're trying to figure out, okay, well, what's the expected return then for each stock? So the first one, let's do stock A. The formula for this, it looks nasty, but it's pretty simple. So expected return for stock A, this R hat is how we symbolize expected return. It's an estimate, kind of like we did with the P hat on that dividend model. So expected return for stock A, we're going to take the sum of the probability of each state times the return of each state. That's your formula. What that means simply is take 25% multiplied by the return for stock A if that happens. Add to that 50% and 15 and so on. Okay, so this is what it would look like. 0.25, 25% times our negative 20% return plus 0.50 times 15% plus 0.25 times 0.35. All right, so solve all of those, add them all up. You should get 0.1125 or 11.25%. So that's our expected return for stock A. You try the same thing for B, work through it and solve it. I'll give you the answer though. You should get 12.5% there. Okay, so that's how you solve expected returns given different states of the economy and a different return in each state. The next piece is a little more complex. Hold on to these two numbers, that 11.25 and 12.5, and then we're going to try to solve variance for each of these and standard deviation. We'll talk more in a second about what that means. For now, let's just try to get through the math here. All right, so looking for the variance. Variance is, symbol for it is this. All right, sigma squared. And your formula is simply the sum okay, so it looks long and lots of Greek in there, but it's really not too bad. All right, so we're just taking the sum, that's all this means, of the return, okay, in each condition, so the actual returns, minus the expected return that you already solved for. So for A, it was this. So take the difference of negative 20% and 11.25, square that, and multiply it by the probability of that happening. And do that for each one. So it gets kind of messy. There's a lot of math, but it's pretty straightforward. I'll write down the answers. See if you can get there also. So our expected return for A was 11.25. Expected return for B was 12.5. So you need that first. You got to get those two parts before you can solve for variance or standard deviation. All right, so let's do A first. So the variance of stock A is going to be negative 20%. That's the RI. This is where it's coming from. Negative 20% minus 11.25%. Sorry, make sure you put that in as a decimal. Okay, so take the difference, square that, and then multiply that by the probability of that happening. Probability of a recession was 25%. Okay, so that's this for the first piece, for this first I, and we'll do that for each one, however many of these you have. You could have 10 different states of the economy or 10 different stocks, whatever you're trying to solve here. You can do it for each one. All right, so that's the first piece, and then you just keep going. 0.15 minus 0.1125 squared times 50%. 0.35 minus 0.1125 squared times 0.25. Okay. So once you solve each of these, add them all up, I got 0.0392. Okay. So that is this. We're saying the variance of stock A is 0.0392. So what does that mean? What is this number? What is it talking about? Well, variance and standard deviation, they're related. I'll show you how in a second. All we're talking about there is risk. And it is risk because it measures how much it varies from expected. All right, that's how we measure risk, total risk at least, in this aspect. So how much does it vary? How much does it move from what we expect? The more it moves from that, the higher the risk, the higher the variance. And remember, in finance, uncertainty is risk. The more uncertain something is, the riskier it is. So this isn't necessarily our return, right? This isn't saying, well, we're getting a 60% return, so it must be risky. Those are related, but this is just measuring strictly how much does it move? How risky is it based on volatility, measured by variance. So how is this related to standard deviation? You've heard that term, you probably calculated it a long time ago in middle school. So variance is the symbol for variance is this, squared. Standard deviation is just this, sigma. So all we do is take the square root of variance and you get standard deviation. So to do that, we're given this 0.0392, that is our variance. So the square root of that solve that, plug it into your calculator. I got 0. Write it up here. Standard deviation equals 0.19802. So there's your standard deviation, and here's your variance. Okay, how much it varies from the mean or from expected. All right, try that same thing for stock B. See what you get. I don't think I've solved this one, but I'll solve it and can post the solutions to all of these so you have that as well. All right, let's look at expected return of a portfolio next. So if you flip over to the back or the next piece of that handout, you're given new information, same or similar concept, but now we're holding multiple stocks and we want to know what our return is going to be. All right, so we're given 5 different assets, stocks or bonds, whatever this might be, and we have different amounts invested and an expected return for each one. Okay, so these are the assets. An invested dollar amount and our expected return for each one. Okay. So first we want to know what are the weights of each asset in the portfolio and the expected return of the portfolio. This is how I calculate your grades in class. The exams are weighted differently, the quizzes are weighted differently, participation, etc. So to figure out a weighted average, that's what we're trying to do here. Okay. So the weights of each invested asset. We've got $15,000, $8,600, $11,000, $9,800, and $5,800. Add all those up, and you get $50,200. So our whole bucket, our basket here with all the assets is worth $50,200. To figure out the weight of each one, the weight of each asset, just divide the dollar amount, 15,000 divided by 50,200. And repeat it, do that for each thing. All right, all the way down. So that's going to give you a percentage amount for each of these assets. If you add up the total of each of these, you should get 100%. All right, or 1, depending on how you set it up. Okay. Expected return for each. That's given. Now, if we wanted, I'll write down each one. So if we wanted to figure out what's the expected return on the portfolio, okay, so expected return on the portfolio, this is very similar to the problem you just solved. Just take your return of each one times the weight, the percentage of each asset, and add them all up. So your formula for that will look like expected return on the portfolio will be the sum of expected return of each asset times the weight of each asset for all your assets, for I equals 1 through however many you have. All right, so this is what that would look like. 12.5% multiplied by the weight of that one, whatever this comes out to be. 9.5% times the weight, 10 times the weight, and add each one together, and you get some return that you would expect for the whole portfolio. All right, I'll work this out and post the solution on Moodle, but give it a shot, see what you come up with for that one. Okay, so that's most of the math for risk and return. The variance and standard deviation is the most tedious for sure. Let's talk through a little more with kind of what this means with stocks and some new vocabulary there moving forward. And I'll give you, I think we have one more formula that you'll use for this chapter. Okay. So with stocks and talking about risk and return, so far this variance and standard deviation, this is a measure of total risk. Just how much does something move? How volatile is that? All right. Talking about stocks only now, just stocks, publicly traded stocks. We're going to have different types of risk. We've got the total risk, and we see how to measure that. But we'll also have what's called systematic and unsystematic risk. So systematic risk for a stock, this is market-wide. It's going to affect everyone. It's going to affect just about all the stocks that are out there. All right, so that's systematic risk. Examples of this would be the coronavirus, right? The whole market is affected by that. Worldwide, I mean, that's a perfect example. Global pandemic is about as systematic as it gets. Other things would be war, inflation, interest rates, taxes or changes in taxes, growth in GDP, all the big stuff. Think big picture things here. Those are systematic risk. Unsystematic risk, on the other hand, is firm-specific. Firm-specific weirdness, basically. So if you have Apple has iPhones and they start catching on fire in people's pockets, right? That's firm-specific. That's going to affect Apple and probably no one else. Maybe it would indirectly affect Samsung or something if people get away from Apple and start using more Samsung or Google or other products. But iPhones blowing up in people's pockets are not really going to affect Exxon or Ferrari or other companies like that. It's firm specific, idiosyncratic, very, very specific things. This could be industry-wide things also, but mainly just think of it this way: systematic, big picture, widespread, affects everyone; unsystematic, firm specific. Okay, so both of these together make up total risk. Okay. Now, as far as stocks go, for what we are rewarded for and what we can measure, this stuff we don't really know what's going to happen, right? Really hard to predict if an iPhone is going to explode in somebody's pocket. But systematic risk we can measure a little better, and measure how exactly do some firm stocks react to big things that happen. All right. So this is the one we can measure. So the way we measure that is called beta, okay? Greek letter beta. So this is how individual firms move in relation to the overall market, okay? So a beta, well, we'll get into that in a second. So how volatile an individual stock is relative to the overall market, okay? We're not going to calculate beta. It'll be given to you. You could calculate it. It's a lot easier to do that on a computer and run regressions than try to do that by hand. Not really necessary, but you can look it up. I mean, we could Google. In fact, give it a shot. Look up a few companies' beta and look at what it says. How about Amazon, Chipotle, whoever else you want to look at, Visa, Tesla, I don't know. Check out a few, look at what their beta is. All right, beta is going to be around 1. Okay, maybe a little higher, a little lower, but a beta of 1 is called the market beta. Okay, if it is greater than 1, so beta greater than 1 is said to be riskier than the market, and the reverse is true. Beta of less than 1, less risky. Now, risk here, we're just talking about volatility. How much does it move in relation to the overall market as things happen? Okay, so typically your tech companies, your newer tech stocks, Tesla, that kind of stuff, they'll typically have a beta greater than 1. Old school companies that have been around forever, Coca-Cola, Procter & Gamble, Johnson & Johnson, Exxon, Chase Bank, those kinds are going to have typically a beta less than 1. All right, so you can look at Yahoo Finance has this data. They're not as reliable, but it gives you a good starting point. MSN Money is a good resource. I think it's msn.money.com. So play around with that. Look up a few betas. See what you find. All right. So if we have a beta greater than 1, it's said to be riskier than the market. And if it's riskier than the market, we would expect greater returns. And if it's less risky than the market, we would expect lower returns, right? Risk and reward, that's what we're studying here. If you take a bigger risk, you expect a bigger reward. If it's lower risk, it's safer, that's fine. You'll expect less reward, less return for it. All right, so that's kind of how this relates. If we put this into an equation to try to solve expected return given beta and given some sort of how the market would react to these systemic risks, we can put all that into an equation and solve our expected return for an individual stock. When we do that, the model that you're going to do is called the capital asset pricing model. Or the CAPM. Okay, capital asset pricing model. This is going to give us an estimate of what we think the stock should return. You did this already with a different model, the dividend discount model, that you solved that and figured out, all right, based on these dividends, we expect stock to be this amount, right? And you could rearrange that model and solve for R, the required return within that. CAPM is the same thing, just a new way of looking at it. We're solving for R, our expected or a required return for a stock. So here's your equation for that. The expected return for a stock equals the risk-free return plus beta of that stock times the market return minus risk-free return. So that's the equation for CAPM. Expected return of a given stock equals the risk-free rate plus beta times the difference of the market return minus risk-free. Okay, so let's talk about what these things are. The risk-free return, think about it. What would be risk-free in theory? What's the closest thing we can get to risk-free? Well, for us, and what we use kind of worldwide is the U.S. Treasury bills. So if you if you loan money to the government, we assume that's pretty much risk-free. They're going to pay us back at that rate. Right now, they're borrowing tons of money, right? Loaning it out to us, but they're only getting that because they borrow it from us and from other countries and whoever holds those bonds. So a risk-free return is U.S. Treasuries. Typically, we use the 10-year rate. So that'll be given. So the Treasury bills, let's say, for example, maybe T-bills are yielding, right now it's really low. It's like 0.75%, so less than 1%. Sometimes they're up around 3%. A long time ago, it was really high, like 7 or 8%. All right, right now we're at almost an all-time low. About 2 months ago, it was an all-time low. All right, so you've got Treasury bills make up your risk-free. Beta was what we just talked about. How much does that particular company's stock move in relation to the market? So an example, maybe that equals 1.25. All right, market return. It's an estimate of what rate the overall market is getting. So usually we'll use the S&P 500. 500 different stocks over the last 10 years or 50 years or whatever timeline you use. What return did those give overall over that timeline? So somewhere around, I don't know, 9 to 10%, depending on the slice of time you use. Sometimes as high as 12, 13%, but somewhere around here. All right, and then again your risk-free rate. So when you plug all this in, let's say this is what we're going to use for our sample company. Let's pretend this is Amazon, and we want to know what is the expected return for Amazon using the CAPM, given this information. Let's say Treasury bills are 0.75%, S&P 500 returning 9%, and let's say beta for Amazon's 1.25. So the return for Amazon would equal 0.0075, really small, risk-free, less than 1%, put it in as a decimal, plus beta 1.25 times the market return, 0.9 minus 0.0075. Plug that into your calculator, see what you get. So I got 11.06%, which would mean our expected return for Amazon, given these assumptions and values, is a little over 11%. All right, so that's the CAPM. That's solving for expected or required return given beta and given risk-free rate and market return. One other thing you need to know about this piece in parentheses, return of the market minus risk-free, it's called your market risk premium. Okay, so that's the premium you get by investing in the market. Whatever market return is minus what you could have gotten risk-free just from US Treasuries. The difference in those is the market risk premium. So kind of keep an eye out there. If I tell you the market return is 9%, then you plug it in this way. If I told you the market risk premium, let's say it was 8%, then that would change. You would just use this 8% and plug it in here in parentheses. You don't have to take out the risk-free rate. It's already done that. This 8% is the market return minus risk-free. Okay, so kind of keep an eye out there. That's really the only area on CAPM where you might get tripped up and just make a small mistake. Other than that, keep everything in decimals. Beta is not a percentage, it is an actual number. So like 0.95 is 0.95. It's not like 9.5% or something. So keep beta as presented. The rest of these are percentages. Okay. So that's the CAPM. Okay, we can also, last thing here, we can also solve for the beta of the portfolio the same way you solved the portfolio expected return. Just different parts to plug in, but it's essentially the same thing. So if we want, we're given several different stocks and we want to know what's the beta of the portfolio? How risky is the whole portfolio? Portfolio just means holding multiple things, which is what we want to do. We don't want to just hold one asset. You want to hold multiple to diversify. Talk about that in a minute. So beta of the portfolio, if we want to solve for that, we would just take the weights of each item, so the sum of the weight of each asset, right, what percentage is invested, times the beta of each asset. That's it, add them up. So let's say we've got 4 different stocks, about Nike, Google, and Johnson & Johnson. And we've got a beta for each 0.1, 5, and 0.7. Just guess these, but that kind of makes sense. Google, tech company, we would expect the beta probably is going to be greater than 1, greater than the market. Johnson & Johnson, pretty safe, been around forever. We expect 0.7. Nike, right around the market. Okay? And then let's say the weight for each, about 30%, 15%, 55%. All right? Plug each of these in. If we want the beta of the portfolio, we would just do 1.1 times 30%, beta of Nike times the weight, plus 1.5 times 15%, beta of Google times weight, and the same for Johnson & Johnson. All right, do that for each one, add them all up, and you get the beta of the portfolio. Okay, so that's beta of the portfolio, variance, standard deviation, and CAPM. It's a lot of information all in one lecture, but I wanted to kind of give you all of that so you have it moving forward. I know I said last thing, but I got one more that we'll throw in there with this. With diversifying. You always hear don't put all your eggs in one basket. Intuitively, that makes sense, right? If one thing explodes or loses value, it hurts a lot more. But if you have multiple assets spread out, you kind of spread your risk. All right, so why is that so good? Because we could say, well, all right, the risk is spread out. I won't get hurt as bad, but I might not get helped as much either. Like, what if I put everything in Apple and they do great? I would get helped a lot more. True. Here's kind of how it works. Let's say we have our expected return on the portfolio. Okay, which you solved already. We had weights of different things, expected returns for different assets. Some were higher, some were lower. Let's say the expected return on the whole portfolio is maybe 12%, which would be great. It's a pretty high return. So this is kind of what happens. Maybe you've got, this year you hold a bunch of different stocks, and let's say this one, whoever, let's call it Lululemon, maybe they do great and they get, like, this line is 12%, so they get like 16 on the year. Awesome. So you lock in 15% with them. But then maybe you've got a few others that are right at 12 and maybe a little under. Maybe this is Exxon, and then you've got I don't know, Burger King, and then maybe way down here, this is, we did really bad this year, oil. Well, Exxon's there. Maybe, I don't know, U.S. oil, it's an ETF. Let's say they got like only 5%. And then maybe somebody did really bad over here. Like you had L Brands, which own Victoria's Secret, and they're actually going private. So maybe they lost like 40% on the year. Okay, so you have all these different assets to do all different things. And really, you've got a lot more than this. Maybe you've got like 50 or 100 of them. So you have all these different stocks getting all different returns all over the map. And the weighted average of each one ends up being right here at 12%. So the benefit is you still get those gains. You still get the good, the ones that do great this year. But you're going to have some misses too. You'll have some that don't do as well. So you don't have to pick, well, what company is going to do fantastic. You hold a wide, diverse basket of different assets. You're going to lock in some that do great, some that do maybe right as expected, some that do worse, and it all kind of balances out. You end up at 12%. So when we talk about risk, systematic and unsystematic risk, excuse me, with unsystematic risk, that's that firm-specific stuff. With finance and financial theory and modeling, we aren't rewarded for unsystematic risk. Okay, so the market, with the models that we're building, the market is not rewarding unsystematic risk. So you're only rewarded for systematic risk, which is measured by our beta. Okay, so as deep as we're going to go in this class with that is beta is measuring systematic risk, how it moves in comparison to the whole market, using the CAPM. This is what you're rewarded for holding. So carrying more risk in terms of beta, you get rewarded for. But this unsystematic individual risk, you're not rewarded for that. The market doesn't reward it. Why? Because it's free to do this. You can diversify. You can spread out and own multiple assets for free. So in theory, you're not rewarded for just investing in one. All right. It's getting a little deep down the rabbit hole with theory, but hopefully that helps kind of paint a picture for how these calculations matter and how you're getting to the final numbers. That's pretty much it for chapter 8. Work through the problems on this handout, and then there's another handout I'll post with some problems. Try to work through those as well, and I'll work through those also. then we'll move on. We've got 2 chapters left for the rest of the semester.